Welcome back, everyone. My name is Navin Reddy, and today we have a guest who will be talking about Docker. Now, Docker is a concept. In fact, we do have videos on Docker on this channel, but then people want more, right? There's no enough content for people, right? They want more and more, and then for the expert as well. And so we are doing a tie-up or collaboration with in 28 minutes, and everyone knows about Ranga, right? A famous Udemy instructor, the bestseller, and he'll be here to talk about Docker. And so we'll be asking huge amount of questions to get our answers. Now, the important thing is, I know something about Docker a bit because I made a series, but then I'll try to behave like I don't know so that you can relate with the answers. And I'll be putting some lame questions as well in between just to make it more interesting. And so we have Ranga. Hey, hi Ranga. How are you doing?
Hi Naveen, I'm doing pretty good. How are you?
Yeah, I'm doing great. Thanks for coming on this channel to share your knowledge. So we are starting with Docker, but then we have a huge plan coming up for different weeks. Right. So are you
Absolutely.
excited for this?
I'm really excited as well.
Awesome, awesome. So let's start with Docker. Let's keep it as possible because people are busy, right? So let's get started with the questions itself. So Ranga, I want to know. In fact, you are working on different cloud technologies. That's what I can see on your YouTube channel. That's what I can see on the Udemy page of your page there.
Absolutely.
So let's start with basics. Let's start with the thing which people are getting confused because as a software developer, when we start working, in fact, recently I was working on some projects, and every time, when you work on current projects, you see some files or some technologies which are working behind the scene. You just edit those files and then things are working. And then for most of the people, they know the technology name, they know the configuration, but they don't know how thing works behind the scene and what's the main use of it. What if they just remove the technology from the behind and replace with something else? And one of the technology is Docker. Because as a software developer, my main focus is to write a code and deploy the code, and then it is happening something on Docker. I don't know how it is working. I just know there's a configuration file. Edit the configuration file and push it on the Docker. It works. So the first question for you, Ranga, just to understand what is the technology. What is Docker? How do you define it?
Absolutely. See, if you look at Docker, there are a lot of parts to it. There is a Docker runtime, there is a Docker image building system. So let's not really get to the technology part of it. Let's start with the use case part of it, right? What are the use cases where you can use Docker? Why is Docker really, really important? Let's start with the first use case. Earlier, let's say I would want to build an application on my local machine, right? What would I do? First, I would probably, let's take an example of a Java application or a Python application. First, I would need to have the OS. Then I would need to install Java. Then probably I would need to configure a few things and then probably install my application and configure a few settings on the application, right? Now, let's say I'm deploying this to dev environment. I need to exactly repeat the same things again. And what we used to do is we used to write these in a document and we used to give it to an operations guy who actually deploys to a dev, QA, stage, production, right? That's how we used to do deployments earlier. You'd need to write a lot of instructions, give it to them, and like people would deploy. And that's why we used to face problems like it works on my system, right? That's the frequent thing. It works on my system, but it does not work on dev environment, QA environment. There's a problem with the staging environment, right? Why does it happen? Because we develop application, but beneath the application, you have the runtime it needs. It needs the OS. You need specific configurations for your OS, maybe your application runtime. Maybe you would miss some frameworks or something of that kind, right? Now, instead of that, how about thinking everything as a bundle? Your OS, your application runtime, your application, everything that it needs, if we can think as a bundle and actually move it around, instead of telling an operations person, hey, operations person, this is the set of instructions, how about actually giving a bundle to them? Just give the bundle to them and they would deploy it to dev, they would deploy it to QA, they would deploy it to stage and production. So that's the first use case, right? There are a number of use cases for Docker, but that's use case number one for me. Now, if we talk about the other use cases, right? Let's say I would want to quickly run MySQL on my machine, quickly run Kafka on my machine, or quickly run RabbitMQ on my machine. Earlier, I would need to download the software, install it, and then it becomes part of my OS and everything. Like if I install a lot of such applications, my system slows down. And that's where, instead of doing that, you can actually run it as a Docker container. So you can say, I want to run this. This is the image, and you can run it. And once you play with it, you can remove it out. So you can easily create development environments with software you'd want. And once you complete a development, you can remove it out. And you can also make it configurable. Anytime you want to set the same thing up in your friend's machine, or if you're in your colleague's machine, you just have a set of instructions, you just run them, and they are up and running as well. So I would say these are the two most use cases. There's a third use case around standardization. I think that will be too complex for now. Probably I'll stop with that for now.
Yeah, true. So the moment you talked about bundle, I can remember, when you, so as a corporate trainer, we move to different places, right? So for different cities. So maybe you're having a training in Mumbai or you're having a training in different country itself. So we have a special bag, where we have everything packed. So if I want to move somewhere, just take the bag and move, so I don't have to again pack and unpack things. So what you talked about is if you want to work with a software on your machine, if it is working on your machine, it should also work on the other environment. So better to have everything bundled so that you move everything together. With that, I have this word which is very common in the Docker world, which is an image. I know we from the virtual machines as well, we are using these terms, get the image, make it work, and run the image. So how do you define, what do you mean by a Docker image?
Absolutely. Right. So I would, as I said earlier, there are a lot of things that you would need to run your application. Like, for example, a specific OS, specific version of a specific language, maybe Java 8 or Python 3. And then I would need a lot of libraries. I might need those libraries configured in a specific way. And I would need the application code. It might be a jar file, a var file, or the code directly. Right. So there are a lot of things that we need to run a specific application. An image is nothing but a bundle of all these things. You say, okay, this is the operating system, and these are the different things which are part of the image. If you look at Docker, Docker uses something called Dockerfile. In a Dockerfile, I can write specific instructions saying first this, second this, third this, fourth this, fifth this. And that combination of whatever we create is called an image. Once you have a Docker image, the biggest advantage is that you can use the same Docker image to deploy it to your local machine, to deploy it to your environments, whether it's dev, QA, stage, or production. In all the places, you can use the same Docker image. Thereby, everybody is using the same image. So once you build it, you can reuse it again and again.
Okay. So the bundle which you talked about is actually an image which you carry from here there, right?
Exactly. And just like whenever you have a bundle, you need to have a place to store it, right? Because there's a common bundle. In Docker language, we call it a repository or a registry, right? So in a Docker registry, what I would do is I would create a bundle, I would put it in a registry, and whenever you'd want to deploy it, you'd pull it from the registry and make use of it.
Oh, awesome. So you talked about two terms as of now. One is a container and one is image, right?
Yeah.
So basically, to run image, so do we need a virtual machine or the container works? I mean, how do we run an image?
Now you have an image. Like you said, these are the things I would need to run an application. You have created an image. Once you have an image, you would want to deploy that image on specific place, right? You'd want to be able to take that image and you'd want to be able to run it. And to run a Docker image, there is a specific runtime which is needed, right? That is called the container runtime. Once I have an image, if I would want to run it, let's say in the cloud, or I would want to run it on my local machine, I would want to run it in an environment, then you would need a container runtime. One of the popular softwares which we install our local machine is Docker Desktop, right? Docker Desktop comes inbuilt with a container runtime. So what I can tell Docker Desktop is execute Docker command saying Docker run this image. And then what it does is it would actually go to the registry, bring the image down, and then it would actually create a container. So a running version of a container image is what is called a container, right? So typically, container is a term which is typically used when it comes to shipping, right? When you have big things that you would want to send from one country to another, what we would do is we would use ships, right? Typically, water is preferred kind of transport for large amounts of things that you would want to ship. And what they do over there is they use ship container boxes. So there are boxes which are present, and it's your role. If you want to send it, what you need to do is you need to fill the box. What the shipping company does is it takes that box and they will only promise that the box will go as it is. And what this helps is now this box is standardized. So in a ship, they can say, I would have 1,000 boxes. It does not matter what's in the box, but I would want to have that boxes, right? So ship is like taking your containers and all the containers on top of it, right? Similar to that is the container runtime, right? When we talk about large machines, very, very, very big machines, what happens is you have the runtime, on top of which you can have multiple containers. For the same container image, I might want to create 5 instances, 10 instances. If there are a lot of users coming in, I might want multiple instances. That's where on top of your container runtime, you would have multiple containers present.
Right. So basically what you're saying is on your OS, if you want to run a Docker image, so of course you can get your Docker image from the repository, right? So maybe public
Right.
repositories or private repositories. And then you run your image on the container. So basically we need to have a Docker container to run the image,
Absolutely.
right?
Absolutely.
So
Yeah.
it's more like a Java runtime for Java.
Exactly. It's the container runtime. So it's like the running version of a container image.
Okay, makes sense. So let's say if I want to build my own image, so I have some bundled, and of course we can get the pre-built images from the repository. But how do you
Absolutely.
build an image? Do we have to use Docker Desktop, or is there any way to build an image?
Absolutely. So you have like Docker Desktop is one of the software which can help you to build an image. But before you'd be able to use Docker Desktop, the first thing that you need to do is to tell what should be part of the image. Right? When I would want to build an
Oh,
image, I would need to tell it, okay, I would want to use this specific version of Linux. I would want to use
mhm.
this specific version of Java. I would want to have this particular var or this particular jar, and I would want to have these thing additionally. Right? So that's what we would need to configure in something called a Dockerfile. So in a Dockerfile, you'll put all the instructions that you want to use to build your Docker image. And once
Okay.
you have a Docker file, you can actually run the Docker commands to build an image. You can say Docker build and give you a Docker file, and it would build an image for you. And that image is
Okay.
what you can actually take it and you can push it to a container registry.
And this Docker file is an XML file, right?
This Docker file is a simple text file. If you look at a
Oh,
few,
okay.
yeah, it is a simple text file where you would have a set of instructions which are present.
Awesome. Because I hate XML, and so it doesn't matter which
No,
technology I work
it's
on. I try to avoid XML files.
no, it's not an XML file. Actually, like
Okay.
typical Docker files for application will not be more than 10 lines of code, right? They are very, very
Oh,
simple. And if you actually hate Docker files, there are also plugins which can
mhm.
work without even having a Docker file. So
Okay.
if you look at Google, like the thing is like with respect to container images, efficiency is very, very important, right? So you would want to use the minimum possible, like the Docker image should be small. And when a
Mhm.
Docker container is run, you don't want to consume a lot of memory. Therefore, your Docker,
Okay.
and also another thing is, let's say I'm building an application, I build a Docker image. Again, I would want to make a change and build another Docker image. I should be able to build a Docker image quickly. So there are a lot of best practices in how you build these Docker images. And
Mhm.
there is a plugin which is offered by Google called JIB. If you use JIB
JIB.
plugin,
Okay.
JIB. If you use JIB plugin, you don't need to have Dockerfile. All that you need to have is Spring Boot code, and it would automatically generate an image for you. So you just need to execute a few commands, and it would automatically generate an image for you. And it also follows
Awesome.
all the best practices related to Docker images.
Awesome. I love plugins where you don't have to, I love everything where you don't have to actually do the configuration. I remember when I was working with Spring and then someone told me about Spring Boot, I was so excited. Now less configuration. So, I love
Absolutely.
technologies provided we don't have much configuration to do. Let me share you my experience with Hyperledger Fabric, the blockchain. So I spent around 1 year, almost 1 year to learn it. And 70% of time I wasted in doing the configurations. You know
Yeah,
the pain, right,
absolutely.
of the
Yeah,
configuration.
it's again, it comes down to the maturity, right? So if you look at the Java ecosystem, it has matured a lot. So because we have started almost 2 decades back, and today we are at a state where we can deploy applications focusing just on the business logic. But I'm
Right.
sure it's not the case with blockchain, right? Blockchain is still emerging, and
Yeah,
I'm
true,
sure like before we reach a particular stable point, it will be a while.
true, true. Hopefully that day will be coming soon where we don't have to do the configuration, just click a button and the blockchain will be there. In fact, yes, IBM has a solution there. We just have to, in fact, IBM, Amazon, they have solutions where you just have to click, 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 and you'll be getting the service ready. But then again, for the customization, again, you have to do the
Okay.
configuration.
Okay.
Okay. Yeah, coming back from the blockchain world to the Docker. So you talked about the repository, right? So we can find the images on the repository. So what these repositories are, because for Maven, we have Maven repository, we have different repository where we can push our jar files, right? Do we have the same thing for Docker where you have a public repositories?
Absolutely. So what we are talking about in here, Naveen, is the fact that we build images using a Docker file, and then we would push image to a Docker registry. So the Docker registry or the container registry is this one which you can see in here. This container registry is the one which we are referring to right now. So whenever we talk about container registry, what you can do is you can push images to it. So if let's say I have a piece of code, I would want to build a container image, I can build it here and then push it, and it goes into a container registry. There are public registries as well, right? If you look at the most popular one right now, it's Docker Hub. So Docker Hub offers you a public registry. Even there's a public Docker registry associated with GitHub as well. And if you look at each of the cloud platforms like AWS, Azure, and Google Cloud, even those offer a lot of registries. So this is where all your Docker images would finally be deployed to. So you can actually build an image and push it to the registry, and each of the enterprises uses a specific kind of a registry.
Makes sense. So this is the Git, and then you build an image, you push the image goes to the registry. Okay, and then deploy. Okay, cool.
Yeah, absolutely.
This
So
image
somebody
is
commits a piece of code into their source control. What would happen is, typically you will have a continuous integration cycle, right? When we have DevOps, what we would do is continuous integration. So somebody commits code in, we would, as part of your continuous integration cycle, you would actually build an image. And to build the image, we make use of the Dockerfile. Once the image is built, we would want to reuse that image again and again. That's where we would actually do a push image. Once you push an image to the registry, from the registry, you can deploy it to any environment. You can actually deploy to dev, QA, stage, or production environment.
Awesome. Now this makes sense, right? How the flow goes. And this is very important. When you know the flow, you can actually understand the different files in the system. Awesome.
Absolutely.
Yeah. So basically, when you have a Docker, and then so in Docker, you have a container where you can run the image. So everything makes sense. You have a public repository. Now there are two commands which you normally run. I remember there's one command which is Docker, and the second command we use is Docker Compose. In fact, before that, I have one more question. You talked about Docker Desktop, right? And I think that is only for Mac and Windows, right?
Yeah.
And for Linux, we use normal Docker installation.
Exactly. So, there are multiple different ways for different operating systems. But at the end, what you get is a Docker runtime and also something to build your Docker image.
Okay, great. Because I remember when I was working on Docker, it's been a long time. It's almost 2 years now. It was when I was not able to install Docker on Windows because I was having the home edition of Windows, and it does not support enterprise features. Is it still applicable or?
No, there are a few issues there, right? So the older versions of Windows specifically have problems in running Docker. There are workarounds. You can install some older version of Docker and things like that, but it's still an issue.
Oh, okay. So better to go with Linux or Mac, right? For Docker.
No, I would say go with latest version of Windows if you are on Windows.
Okay. Cool. Yeah. So those two commands, one is Docker and second is Docker Compose. So what is Docker Compose?
Absolutely, right? So when until now we have been playing with one application, right? Let's say I would want to I'm working on a REST API or a microservice. One microservice I can launch up using Docker. I can create a container image for it. I can run it. All that can be done using Docker. But let's imagine a scenario where to run my microservice, I need another microservice, right? I can execute individual Docker commands to launch up microservice 1, launch up microservice 2, launch up microservice 3, and all that stuff. But let's say I would want to be doing it in a much easier way. That's where Docker Compose comes into picture. So in Docker Compose, I can say, okay, I would want this microservice, this microservice, this microservice, and this is the database also I would want to launch up. So you can configure the container images for all the things, and with one single command, your entire ecosystem comes into picture, right? If you look at our microservices course, for example, what we do is we create a Docker Compose file, and we launch up Eureka naming server, we launch up the centralized config server, we launch up the distributed tracing thing, this Zipkin, and we launch up 3 microservices. And to launch all that up on my local machine, I just need to execute one command. So Docker Compose allows you to launch multiple containers without executing multiple commands. And also, there would be dependencies between these containers, right? It's not like the microservice independently works. This microservice needs to know where the Eureka server is. This microservice needs to know where the queue is. So all that configuration also can be part of your Docker Compose configuration. So therefore, you can set it up in such a way that, for example, if I'm launching up a local environment, a lot of times what happens is to launch up a local environment might take 1 hour because my microservice is dependent on something else. I need all that configured. To configure that takes a long time. And that's where if you have one Docker Compose file, you run it, everything is ready. And you can actually start working on your thing without worrying about whether there is a database and all that stuff.
Awesome. So for multiple services, we can run multiple containers, and to run them together, and to bundle them, we use Docker Compose, right? That's what it makes sense.
Absolutely. So in your local machine, Docker Compose is really, really good, right? If you go further, like to launch multiple containers, there are other options. But for local machines, in my own local machine, for development purposes, Docker Compose is a really good option.
Okay, I want to know those options. Is it you're talking about Kubernetes here?
Exactly. So, if you look at the evolution, right? So, we started with Docker. We were happy with running one container. We standardized it. Will we be happy with it? No. We want to do more. Now, let's say I have 10 microservices, 20 microservices. I would want to be able to run containers for all of them, right? I'm not happy with running one container. I'd want to be able to run 100 containers of each microservice, and there might be 1,000 microservices. And that's where we go into the container orchestration world, right? We would want to be able to launch up containers. Like, let's say there are 10 users on the application. I need less number of containers. But if there are 1,000 users, I would need a lot of containers to be able to handle the load, right? So I would want to be able to have something which handles that, which automatically sees, hey, there are a lot of requests coming in. I would want to increase the number of containers. And also, these containers, you need load balancing, right? If I have 10, 15, 20, 30 instances of microservices, you'd want load balancing between them. So there are a lot of features that you would need other than just the containers. And these features are what are called container orchestration. If you looked at the most basic container orchestration solution, it's called Docker Swarm. Actually, I wouldn't call it basic. I would say it's the first container orchestration solution which was popular. So Docker, like the company which made Docker, also released Docker Swarm, right? Docker Swarm was good. It was getting popular. But in between, Google came up with this thing called Kubernetes. And like installing a Kubernetes cluster was difficult, but once you have a running Kubernetes cluster which is working, using Kubernetes is much more easier, and it provides much more flexibility than going for Docker Swarm. And that's the reason why today, like Kubernetes is one of the most popular tools out there.
Right. Docker Swarm, right? In fact, for the viewers, I would recommend you to watch a video on YouTube. This is from Honeypot. So they make documentaries on different technology, and they recently launched 2 videos on Kubernetes. Part 1, part 2. See the what is the video name? The Kubernetes.
It is called the Kubernetes documentary.
Yeah, an awesome video. So
Absolutely.
You get motivation. So how they build the technology, and then how. So one thing I learned, from my experience. So whichever company or the freelancers or the community, when they build a technology, there's no surety that this technology will be famous. It all depends upon how people are pursuing it, how they are using it, what are the use cases they're using it for, and that's how the technology evolves. And it's the same story happens for the Kubernetes.
Exactly. Right. Especially in the open source world, I think it's very, very tricky, because you need contributors, you need users, you would want to build an ecosystem, you also want to control the direction in which it's going, what are important, what are not important, what are the focus areas. So making sure that you are able to make those decisions without like alienating other people. That's where I think Kubernetes was really successful.
You mentioned it right. Direction is very important in the open source world, because we have a lot of contributors. So we have a vision for what we are building. So that everyone will contribute their own features, and it will make a software which is going in all the directions, but it's not having a perfect vision. That's right. Awesome. So now we know how do you build an image. So we build an image, we run it on the containers, and it works on the local machine. But the world is moving, right? Nowadays we run the applications not on our local premises or on premises, we run it on the cloud. So how do we run the containers on cloud, or do we have the Docker support on all the clouds available, or do we have to choose one?
Absolutely, right? So if you look at, I'll take a step back, right? So if Docker was the first container format which became really, really successful, right? But in between, what happened was we wanted standardization around the Docker thing as well. So we did not want to just restrict to Docker, but we would want to have some standardization. If I have to give an example, this is very, very similar to Hibernate. When Hibernate came in, that was the most popular framework if you'd want to do ER kind of storing to the database. And in between, Java came up with the JPA, Java Persistence API, which is an API. So JPA is the interface and Hibernate is the implementation, right? Now, the advantage of going for JPA is that you can shift from Hibernate to some other thing, like top link or whatever. It rarely happens, but you have the option, right? So you have the option to shift to some other thing if you go to the interface. Similar to that, what happened is with the Docker thing also, a lot of people started adopting Docker. And that's where there was a need for an open standard. And that's where there was an open container initiative where it's defined that this is how the Docker image structure or the container image structure will be. And this is how the container runtime is. So you would frequently hear the terms OCI, CRI. So CRI is Container Runtime Interface. OCI is Open Container Initiative. So the thing is, now the container world is not just restricted to Docker. There are other runtimes which are getting popular as well. So things like Rocket, and there are a few other container runtimes which are getting popular, right? So now, like when you go to the cloud supports these container runtime initiative standard. So whatever standard which is defined by the Open Container Initiative, almost all the cloud platforms support it. So you can run Docker containers and any other containers which support the Open Cloud Initiative as well. And if you look at the cloud, right, so there are variety of services based on variety of use cases. Let's take a simple use case. I'm running a web application. That's all I would need. So what I will have to run is just a container image, right? Nothing more. I'll just have one container image and I would want to be able to run it. And maybe the database is outside, like it's already deployed. I just need to connect to it and store my data to it. So for those kind of use cases, there are simple managed services. Like if you have AWS, you can go for something like Elastic Beanstalk. With Elastic Beanstalk, you can just give it a container image and it would be able to deploy and manage your complete application. However, if you want more complex things, right? Earlier we talked about container orchestration. You'd want multiple containers to be run. I would want to do complex things. I would want to manage releases of all these things. In that kind of situations, you can go for container orchestration solutions which are provided by the cloud. So if you look at AWS provides something called Elastic Container Service. So Elastic Container Service can be used to deploy, like create a cluster, and you can actually deploy things into, like we will talk about Kubernetes, I guess Kubernetes and ECS further in the next session when we talk about Kubernetes, but you can actually like do, AWS offers ECS. AWS also offers a Kubernetes solution called EKS. Similar to AWS, all the other cloud platforms also have services. Azure has services called Azure Container Instance, Azure Web Apps. Azure also has a Kubernetes service, Azure Kubernetes service. And Google Cloud has GKE, which is the most popular Kubernetes service. And it also has an offering called Cloud Run, which can be used to run containers. Google Cloud also has something called App Engine, which can also be used to run containers. So, I mean, what I'm trying to say is basically you can run containers anywhere. So, and that's the reason why it's becoming really, really popular, right? So, because once you have the image, you can run it in Google Cloud, Azure, or in AWS, or even in your data center, even in your local machine. So wherever there's a container runtime interface implementation available, you can go ahead and run it.
Awesome. So with this, Ranga, we got the basics, and now we understand. At least some people who are watching this or watching Docker for the first time, listening to Docker for the first time, it makes some sense. Now, I have a very important question for you. Let's see if we can handle this. As a software developer who is just starting in the industry, right? Because in the colleges, we don't learn about Docker and Kubernetes. What you learn is this is the language. This is how you build a software. This is how you test a software. This is how you deploy a software, right? Now, when they move to the industry, when they join their first job, and when they start working on a project, most of the time they get the existing project, right? They don't build a new project. They join the team and they have the entire code base ready, right? So they have the source code, they have all the Docker and Kubernetes cluster running behind the scene, they have the configuration file. So how important is this knowledge we shared here for a newbie? Do they have to learn Docker to really be successful in a software development field, or is it okay? I mean, they know there's a configuration file, they can just edit the configuration file. So how important is Docker for them?
Yeah, I think this is a pretty deep question, Naveen, right? So today, like if you look at last few years, right, something which people can relate to is JSP servlets, Spring MVC, Spring Boot, right? Now the question, if I ask, how important is it to know JSP servlets today, right? I would say it's not really important. I would not really worry about JSP servlets. I would directly, if somebody is starting off, I would say directly jump into Spring Boot, play with it, and you'll face problems, and then you can go and dig deeper, right? So because that's the fastest way to start. And today, like there is so much happening in the technology world, right? So it's not sufficient if I know programming. It's not sufficient if I know to build web applications. I need to run containers, container orchestration, and a lot of other things, right? So I would say focus on the high level. But if you are working in a Docker Kubernetes project, that's the best thing that can happen to you. You already have the playground. What I would recommend you to do is to take 2 hours out of your day, pull up a Docker tutorial, see what commands they're executing, see how people are writing a Dockerfile, and compare it with what you have in your project. Execute the same commands in your project, right? So you have the opportunity to learn it very, very fast. A lot of people think Docker, Kubernetes are difficult to learn. Actually, if you ask me, programming is difficult to learn. Building web applications is difficult to learn. But Docker and Kubernetes are things you can learn in 2 days, 3 days, right? So if you look at the entire introduction and all the complexities related to Docker in, let's say, in our DevOps course, we talk about it for 3 hours only. That is more than sufficient for somebody to use Docker effectively in their project. It's not a complex technology, right? It's one time you learn and you use it across your career, because Docker is such an important thing that containers are here to stay. Earlier, like people used to say, enterprises are going cloud first, right? Meaning, if I would want to create a new application, I would first put it into the cloud. Today, people say enterprises are going container first, in the sense that if I want to deploy an application, I would first create a container. It's not just to web applications or REST API, right? Even data engineering, even machine learning people, right? So today, if I would want to deploy a machine learning workload, they would create a container and give it to you. So containers are becoming so popular, and that's why Kubernetes is also becoming popular, because once you have one container, something to manage this is becoming very, very important. So containers is a very, very important thing. Therefore, I would say dig deeper. If you're working on a project where you're using Docker containers, go dig deeper, understand how it works in depth.
True. So don't skip these steps, everyone. I know you are focusing more on programming, but understanding what is happening behind the scenes is very important. Plus, if something goes wrong behind the scene, you should know what went wrong. It's not like you will change you will put a semicolon and it will start working. So it's important to learn the backend technologies as well.
Absolutely.
So that makes sense.
Just to add on to it, Naveen, learning Docker is much more easier than learning Kubernetes, because you might not have access to Kubernetes cluster. So if there's a production Kubernetes cluster, you will not have access to it. So you might not be able to play with it. But the Docker image is created on your local machine, right? If you want to, so the end-to-end, how your source code is converted into a Docker image, everything happens on your local machine only. So that's easy to learn. Like you can install Docker desktop is installed on your local machine only. So you have complete control over your environment. So Docker is easy to learn. But Kubernetes might be a little difficult because your access to clusters might be restricted.
Right. And that's the reason I'm not into Kubernetes, because I don't have a Kubernetes environment here. Awesome.
Absolutely.
Yeah. So probably next week, Ranga, let's talk about Kubernetes if that works.
Yeah, sure. We will definitely talk about Kubernetes.
Yeah, because after this session, there's so much of hype of Kubernetes for this for the next episode. Great. So thank you so much, Ranga, for these awesome answers, and we will be continuing with this journey on cloud as well. Everyone, please let us know your feedback in the comment section and what technology you want to learn in the coming weeks. Of course, next week we are planning for Kubernetes, but if you want something different, let us know. We are here to listen to your thoughts, and do check out the channel on YouTube. I will put that in description. And Ranga is also there on Udemy. You can check out the courses. And of course, everyone knows about you and Udemy, but yeah, just to mention that. So thank you so much, Ranga.
Thanks a lot, Naveen, for hosting me.
So bye-bye, everyone.
Bye.